Hi guys, today let's look at the Lintcode problem number 7, binary tree serialization. This problem is a little bit hard, a little bit long when you do the coding. So let's look at this problem. This problem is very simple. You're given a binary tree, it's like this, and you need to serialize it and deserialize it. So that's what we need to do. So usually we serialize the tree in this way by layer. For example, we have the tree here, right? We serialize it to a string like this. This is the root, and we serialize the second layer, which is the 920, and we serialize the third layer. The third layer actually, first we serialize a nice children, but 9 got now left the children and now right children, so we just put the pound sign here. So then it's 15 and 7. So that's how we serialize this whole tree. Because in this whole serialization process, we identify their noun children. So this layer, this serialization by the layer order can uniquely represent a binary tree. So that's our goal. As long as your string can uniquely represent the binary tree, so that's a good serialization. So when you deserialize it, it won't got any problems. All right, let's look at the right side, the solution side, how we're gonna do the coding. I added a lot of Chinese comments. If you don't know Chinese, you can just ignore it. All right, so this is the serialization part. We're given a binary tree root. So first, we're gonna check if the root is noun or not. If it is a noun, we just return curly braces. We realize that when we do a serialization, we use curly braces, at the both end. All right. So if the tree is a good tree, it has some children, then we're gonna just use a queue. I call it a queue, and actually it's just a Python list, and we put this root into this queue, and we use the index, initialize the index to be 0. The index is gonna point to the queue to help us to access the elements in the queue without the dequeue the elements. So now we're gonna just do the index less than length of the queue. That means if our index reaches to the last elements of the queue. If not, this while is gonna continue. Now we're gonna just access the elements in the queue. The way we access it is just to call queue, then we give the index, and we get the index, we get the elements from the queue, and we check if it is noun or not. If it is not noun, and we're gonna just append its left children and append its right children. We put left children and right children into the queue. We know that this is actually this is the layer. This is the like traverse the tree in layer order. So after that, in our queue, it's gonna be like a 3, 9, 20, noun, 15, 7. So that's what our queue is gonna be. Every time when we access the queue, the element in the queue, we're gonna just increase the index by 1. So let's look at this left side. For example, we initialize root, we put the 3 into the queue, and in a while loop, we dequeue. The first element is 3. So then we're gonna just put the 3's left children into the queue and 3's right children into the queue. Then after that, we have 3, 9, and 20, and we increase the index by 1. Then index right now is going to be 1, so we're going to just access the node 9, and we get node 9 from here, and we're going to just put the 9 left children and right children into the queue because it is a noun, so we put the noun into the queue. So same thing, it just continues until we access the 7, the very end of the the queue. So this while part actually just to do the layer order travels and put the elements into the queue, right? So once this is done, we still have to do another thing. We have to check if the last element of the queue is null. If it is null, we're going to just have to pop it out, because we realize that if we access the 15, 15 got the null left children, null right children, and 7 got null. It's all going to be just appending to this queue. But actually, when we do the serialization, we don't need the null there, because it won't help us. As long as we have this, and we can just uniquely represent the whole tree. So here we have to do some cleanup here. If the last element is a null, we just pop it out. So after till this, we finish our core logic, and then we have to just make it a string. So this is how we make it a string. This is our queue, and for each node in our queue, and we're going to just make them a string. We just get the value and converted them to string, because the value in the tree right now, it is integer. And also sometimes the node is null, right? So we check it here. If the node is not null, then we put its value. If it is null, and we put pound sign. And also eventually we use the comma to join all the elements together, and then we use curly braces to make it string like this. So this is how the serialization part is done. So this part is done. So second, let's look at the deserialization. Deserialize this function is going to take one input, which is like this. It's a string. So first we're going to check if this string equals to curly braces. If it is, then it's going to be a null, because here when we do the serialization, if the root is a noun, the tree is the noun tree, we just serializing this way. So here we also have to check this situation. If we got some data, and we're going to just take the take out this first one, take out the last one, so we get the data part. And for data part, we got the comma separated strings, right? So we just split them, so we get the array of the values. So obviously the first one in the array is going to be the root. So array 0, we convert it to an integer, and we construct the tree node. Now we got the root. Same thing here, because we're using a queue when we do the serialization in layer order. So here we'll also do the same thing. We create a queue, which is Python list, and we'll put this root element into this queue. And also we need to construct this guy's left children, right children. So we need to have some flag to tell when to construct the left children, when to construct the right children. So at the beginning, it's going to be left children. So we mark left children to true, and we mark this left index to be 0. Now we're going to just use the for loop to do this, to construct this whole tree. We already construct the root, then we just need to construct the remaining. So once this is done, we just return this root, which is the binary tree. So let's look like this core logic. Because we already take the the first element in the array, so we just started with the second element, and we're gonna have to check if this element is not pound sign. That means we have to construct the element. So we just construct a tree node. We get its element, and we have this tree node here. So if this is left children, we're going to just assign this guy to this current element left children. Otherwise, it can be right children. And then we append this guy into the queue. So every time when we access one element, and we're going to just change the flag. So if this flag becomes the left children again, that means one layer is done. We're going to one element is done, because each element we check its left children, right children. So that means one element is done. So we just increase or move forward this index pointer. So it just continues until we reaches to the very end of this queue, for example 7. Then this whole thing is done. Then we just return the root. So let's do a test run. Looks great. So that's today's algorithm. Thanks, and see you guys later. Bye bye.